Okay. Hi everyone, my name is Tamay and I'm from the Chair of Media Technology at the Technical University of Munich. And today I want to present you our delay compensation approach for a stereoscopic 360-degree telepresence system. So first of all, I want to motivate the problem we are trying to tackle. So this is the scenario we are considering, and what we have here is like the user on a local side wearing a head-mounted display, and on the remote side we have a 3D vision system, and in between we have the communication network. And what we want to have is like we want to provide a three-dimensional, 360-degree immersive experience of that remote environment. And when we speak of 3D, we refer actually to the human vision system. So what we want to have is like we want to provide different imagery from separate vantage points or perspectives for each eye. And this allows the sensation and perception of depth information. And we solve that by providing a stereo camera system mounted on a pan-tilt roll unit, so to mimic the user's head motions. I mean, such a system has many benefits. It's low cost, it's lean and real-time capable, but it comes with a really big disadvantage. And this arises from the total delay which occurs during such a system. So the accumulated delay leads to a so-called large motion to photon latency. And this latency describes the time needed to reflect the user's head motion onto the display. And if this latency is too large, the user will experience visual discomfort, and this will lead to motion sickness, and in the worst case, it can lead to the termination of that telepresence session. So in this paper, we propose a delay compensation approach, and this is like the higher level methodology of that. So what we do is actually we capture slightly more imagery. So this is the blue image plane of a fisheye camera. So we use equidistant fisheye cameras, then actually display to the user. So when the user rotates the head to the right, for instance, we can use this residual imagery for local delay compensation. And this allows the camera to follow and provide the updated frames. And we provide by this an instantaneous visual response. To further improve the delay compensation, we propose a probabilistic head motion prediction. And actually it's a modification, so we trained a probabilistic error model, which can be applied to any desired forecasting method. And what it does, it weights this predicted value with its probability to be at that orientation. And here you can see the higher level control scheme of our system. So on the left side, we have the user again, we have the network in between and the server for the 3D vision system. And what I want to point out is that we do this compensation and prediction approach on the client side. Here you can see the system in real. So we have the user with the HMD and then this vision system which follows the motion. There's a real network in between, but since the distance is pretty small, the delay is also pretty small. Now I want to show you at least one result. So here we have a total delay of 500 milliseconds. And what we do here is like we compare the raw setup where we have no compensation, no fisheye camera, to our compensation approach in combination with this probabilistic head motion prediction. And here you can see on the left side the camera without any compensation. And what we show next to it is like the compensation rate. So this is a metric we propose and which describes the achievable level of delay compensation. It goes from 0 to 100%, where 100% means complete compensation. And you can see that if you don't have this compensation approach and no prediction, the camera will always lag the head motion. And if you apply the compensation approach with the fisheye camera and the probabilistic head motion prediction, you can see that for this specific head motion profile, so this is a real head motion profile of a user, we achieve almost 100% all over the time. So yeah, that's it. If your interest is raised or you have any other questions, feel free to reach out to me during the